Hello students, in lesson number 8, let us move further. In the previous lecture, we were calculating the numericals based on the equations of motions, right? So, again we are recalling the equations of motion. V is equal to, first equation is V is equal to U plus AT, S is equal to UT plus half AT square, and 2AS is equal to V square minus U square. These three equations we are using in numericals. Now let us do the next example, that is example 8.7. What is the question? The brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction of the motion. So wherever there is a numeric, whenever we are doing the numericals, we need to understand the problem first. Okay? These are the steps to do the numericals. First, understand the problem. Then list out the data given in the numerical and then see what we need to find. Then use the proper equations. Okay, appropriate equations should be used to calculate the values. So we are understanding that one car is moving and then the brakes are applied. Okay, so it produces an acceleration because it changes the velocity. So we can say that the acceleration is produced. And how much acceleration is produced? 6 meter per second square in the opposite direction of the motion. Why in opposite direction? Can you understand that? Brakes are applied. Okay, you are going in a vehicle in one direction. So wherever you are applying the brakes, acceleration will, your velocity decreases. Okay, so we can say that the acceleration in opposite direction. Okay, and wherever you accelerate the vehicle, your velocity increases, the acceleration will be in the same direction of the motion. So remember this thing, wherever the brakes are applied, wherever the velocity slow down, the acceleration will be in the opposite direction of the motion. Okay, so that opposes, okay, acceleration is in opposite direction, that's why the velocity decreases. And wherever the velocity and acceleration are in the same direction, the velocity increases. So the 6 meter per second square acceleration is in opposite direction of the motion. If the car takes 2 seconds to stop after the application of brakes, okay, after 2 seconds the car stops. Calculate the distance traveled during this time. So during this time when it stops, how much distance car has traveled. So the data is given, acceleration is given, 6 meter per second square in opposite direction. See, these quantities, the directions are also should be mentioned. Okay, so minus 6 meter per second square. Opposite. Remember this. Wherever there is opposite direction, minus sign is taken. Okay, so acceleration is 6 meter per second square, but we are taking minus 6, which means that acceleration is in opposite direction. Okay, t is 2 seconds and the car comes to rest. Okay, it stops. It means final velocity is 0. V is 0. So how much distance S we need to find? So for distance we have two formulas. S is equal to UT plus half AT square and 2AS is equal to V square minus U square. Let us see that which we can use. For distance, do we have U? We have U? No. We have P, we have A, yes, we have T. For the second equation, let us see, we have A, yes, S we need to find, V we have, but U we don't have. So in both the equation, U we don't have to find the distance. So first we need to find U and then that U can be used in for the next equation. So we are using the first equation to find U. That is initial velocity, because we don't know how initially by which initial velocity the car is moving. So we know that V is equal to U plus AT. Put the values. V is 0. Yes. U we need to find plus A, that is minus 6. And all are in standard unit only, so no need to answer. A is minus 6, T is 2. V is 0, then 0. U plus minus 6 to the 12. minus 12 goes to that side, becomes plus. So u is equal to 12, and as it is a velocity, the unit will be meter per second. So initial velocity is 12 meter per second. Now we can find the distance. So the distance traveled, s is equal to ut plus half at square. We use that formula. U is 12, t 2 plus 1 upon 2, a minus 6, t square, that is 2 square. 12 to 24 plus minus minus. This 2 can be cut with 6. 2 3s are 6 and 3 into 2 square 4. 4 3s are 12. Okay, this is a simple mathematics. 24 minus 12, that is 12. So S is 12, and as it is a distance, the unit will be meter, right? So S is equal to 12 meter. So car will travel 12 meter distance and it stops. Okay? So this is how the simple problem can be solved. Now, in page number 109, the in-text question answer in the first one. Question 1. A bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Okay, again understand the problem. A bus starting from rest. That means initially is it at 0 velocity. So in data we can list out that u is equal to 0. Okay, given u is equal to 0 because it's starting from rest. Okay, these are the key words. Then it moves with a uniform acceleration of 0.1 meter per second square. So a is given 0.1 meter per second square. It will be positive or negative. Starting from rest, it increases, it starts moving. It means the velocity will increase. So a will be positive. The acceleration will be in the same direction of motion. So a will be positive, 0.1 meter per second square, standard unit, for 2 minutes, and it will travel for 2 minutes. T is equal to 2 minutes. It is not the standard unit. We need to convert. So 2 into 60 is equal to 120 seconds. Find speed acquired. So by this acceleration, how after 2 minutes, what will be the speed of the bus? The speed acquired and the distance traveled during this 2 minutes that we need to find. So speed acquired, that means the final velocity. Initially the bus is at rest. Now after applying acceleration, the speed is acquiring some final velocity. So that final velocity we need to find. V and S we need to find. First one. Okay, so A, according to the velocity time relation. Okay, which we need to we are using the equation. First equation we can use V is equal to U plus A, that is for the final velocity V. Okay, so and that relation is the velocity time relation. You can use this kind of words according to the equations of motion, according to the velocity time relation. This kind of sentences you can use in between. Okay, that will be good representation. So according to velocity time relation, V is equal to U plus AT. We have that. So put the value, V need to find. U, what is U? 0. Plus A, that is 0.1, and T is 120 seconds. So 0, again, 0 we are not writing down. 0.1, that means 1 upon 10, yes, into 120. So 0 cut, 12 was 12 upon 1, so that is 12. As it is a velocity V, so final velocity will be 12 meter per second. Bus will acquire 12 meter per second velocity. And another thing we need to find distance traveled. S is equal to ut plus half at square. We are directly using this because we have u, we have t, we have a. We can use that. So u is 0, t 120 plus 1 upon 2 into a. A 0.1, so we can directly use 1 upon 10 into t square, that is 120 into 120. 120 into 0, always 0, plus 1 0 can be cut with 120 and 2 will cut with 2 6 are 12. Right? No question now. So 6 into 120, 12 6 are 72 into 0. Into 0, no, but 1 0. 12 6 are 72 and 0. So 720 plus 0, that will be 720. And as it is a distance, the unit will be meter. So distance traveled by a bus will be 720 meter. Okay? We are not converting into kilometer because 720 meter only. If it is bigger number, then it will be converted into kilometer. But here meter is convenient. Okay? Units are there for our convenience. Okay? If the distance between the two cities, we are using kilometer, not meter. Okay? But then length of the scale, length of the bench, okay, that is which is used, meter can be used. Okay? But if we can say that size of an ant, that will be in centimeter or even smaller number. Okay? So units can be chosen for our convenience. So 720 meter. Third, next question number 2. A train is traveling with a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. So you can understand the equation, understand the problem. Train is traveling with a speed of 90 km per hour. It means that is its initial velocity. It is traveling. When you observe the train is traveling at 90 km per hour, and then brakes are applied. Now the brakes are applied. So its velocity decreases. That means acceleration will be in the opposite direction. So it is given uniform acceleration of minus 0.5 meter per second. It is already given, negative. But if it is not given, you need to take negative. So minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. Brought to rest means after applying the brakes, the train stops. It brought to rest. It means final velocity is 0. So can we list out the data? Yes, given u, initial velocity is given 90 km per hour. Train is traveling with 90 km per hour. So kilometer per hour should be converted into meter per second by multiplying with 5 by 80. So 90 into 5 by 80 is equal to 18 5 90, 5 5 25 meter per second. Very simple. Acceleration is given negative 0.5 meter per second square. You know why it is negative? Because acceleration is in opposite direction. V is 0 because it brought to rest finally. And S we need to find. So which equation we can use? We have two equations for the distance. For second equation, ut plus half at square. U is given, yes, t. You can see that time is not given. How much for how much time the train is traveling, that is not given. So time term is not given. So we can't use this second equation. But for the third equation, A is given, yes. S we need to find, V is given, yes, and U is also given. So we can use the third equation. Okay? According to the given data, we can choose the equation. Only one quantity should be unknown, other quantities should be given. Then you can use it. Otherwise, if you can find the t from the another equation and then use that t, that also will be okay. Okay, so directly we are using the which equation it is? It is the position velocity relation. So according to the position velocity relation, 2as is equal to v square minus u square. Put the value 2a is minus 0.5. So can I write 5 upon 10? So minus 5 by 10 into s is equal to v square. V is 0, u0 square minus u is 25 square. So see here, 2 5s are 10, then 10 will be cut with 10. Okay? In denominator that is 5 to the 10, in numerator it is 5 to the 10 and denominator also 10. So that will be cut. So minus s is equal to 0 square 0 minus 25 square 625. So minus s is equal to 0 minus 625 is minus 625. Minus minus cut on both sides, so s is equal to 625. As it is a distance, the unit will be meter. So distance s is equal to 625 meter. So the train will travel 625 meter and then it stops. Okay? So this is how the three equations can be used to solve the simple problem like this. Okay? The problems of motion. Further, the third question. Question number 3. A trolley while going down an inclined plane has an acceleration of 2 cm per second square. What will be its velocity 3 seconds after the start? So what is the problem? One trolley is there which is going down an inclined plane. So like this. And its acceleration is given 2 cm per second square. So A is 2, given data A is 2 cm per second square. Will it be positive or negative? So then, give the answer. While going down, while the trolley is going down, its velocity will increase or decrease? Yes, the velocity, while going down, the velocity increases. So, for the increase of velocity, acceleration is positive. So, A will be plus 2 cm per second square. Do we need to convert into meter per second square? See, time is given 3 seconds. Here, in both the quantity, time is of the same dimension, second. Okay. So, if we are not converting the centimeter per second square to meter per second square, then we need to find the velocity. Velocity will be there in centimeter unit. Okay, centimeter per second unit. So it's okay if you, as because the time is same and other quantities are in same dimension, we don't need to convert this centimeter per second square to meter per second square. Okay. So t is 3 seconds. There is no problem because both are in second. V, what will be its velocity 3 seconds after the start? This is the key word. It starts, after 3 seconds, what will be its velocity? So, its initial velocity is 0 because it's after the start. And what will be its final velocity after 3 seconds? So, final velocity we need to find V. Simple. We have the first equation to find the final velocity. So V is equal to u plus et. We can use this equation, velocity time relation. So V is equal to u plus et. U is 0, A is 2, and T is 3. Right? So 0 plus 2 3 are 6. So now, as the acceleration is centimeter per second square, the velocity will be centimeter per second, not in meter per second. Right? So V is 6 centimeter per second. Not in standard unit, but still there is no problem if the units are of the same dimension in a particular question. Okay. So V final velocity is 6 centimeter per second. Further, question number 4. A racing car has a uniform acceleration of 4 meter per second square. Acceleration of a racing car is 4 meter per second square. What distance will it cover in 10 seconds after start? Again, there is a keyword, after start. So, given is A 4 meter per second square, U is 0. So, it starts after start, okay? It starts from rest. That means the velocity will increase. So, acceleration will be positive. So, U is 0, A is plus 4 meter per second square, and T 10 seconds. What distance will it cover in after 10 in the 10 seconds? So S we need to find distance traveled. For the distance we have second formula ut plus RAT square. We have U, we have T, yes. We have A, yes. So second equation we can directly use. S is equal to ut plus half AT square. U is 0, T is 10 plus 1 upon 2, A is 4 and T square, that is 10 square. 10 into 0, 0 plus 2 can be cut with 4. So 2 2s are 4. 2 into 10 square, that is 100. 100 into 2, 200. So 200 plus 0, 200 meters. So the racing car will travel 200 meters in a 10 seconds. Very simple. Next, question number 5. A stone is thrown. This is an important question. A stone is thrown in vertically upward direction. Vertically upward means from here, ground, the stone is thrown upward with a velocity of 5 meters per second. So, it thrown with the velocity. So, it means its initial velocity is 5 meters per second. If the acceleration of the stone during its motion is 10 meters per second square in the downward direction. Understand this problem. Whenever you are throwing a stone, any object, in the upward direction, its velocity increases or decreases? Yes, the velocity decreases. That means that acceleration is in opposite. Motion is in upward direction, acceleration will be in downward direction. Both are opposite. So, and velocity decreases and acceleration will be negative. So, acceleration is 10 meter per second square in the downward direction. What will be the height attained by the stone? How much height it will go? And how much time will it take to reach that? So, what is the data given? U is 5 meter per second. We are throwing this with 5 meter per second. A will be negative 10 meter per second square. Why negative? Because the velocity decreases and acceleration is in opposite direction to the motion. That's why it is taken negative. What will be the distance? What will be the height attained? That means how much distance the stone will travel. So height is nothing but the distance traveled and how much time it will take to reach them. T we need to find, and V is equal to. So to find the distance, we have U, we don't have T. Okay, we have A, but we don't have. For the third equation, A we have, V we don't have, U we have, V we don't have. What is final velocity? Understand me, wherever something is thrown upward, when it reaches to some point, it stops there. Okay, and after stopping, it starts its downward motion. So for the upward motion, the object will stop. So its final velocity is 0 for the upward motion. Okay, so V is 0 because it stops at that point and then it again fall down and doing the downward motion. So which formula will we use? For if we want to use the second formula, we don't have T. So can we use the third equation for distance? Yes. A we have, V we have, and U also we have. Okay. So according to the position velocity relation, 2as is equal to V square minus U square. Put the values. 2a is minus 10, s is equal to V is 0, so V square 0 minus U square, that is 5 square. So 2 into minus 10, that is minus 20 into s, is equal to 0 minus 5 square 25, that is minus 25. So minus minus cut on both the sides now. Now 20s. 20 is in multiplication with s, so on that side it will go in denominator. So s is equal to 25 upon 20. Can we cut with 5? Yes. 5 4s are 25, 5s are 25. So 5 upon 4. If you divide it, its decimal expression will be 1.25 meter. So S is 1.25 meter. So now we have S and now we need to find T. Okay. So from the first, in this two equation we have T. So in the first equation we have V, yes. U, yes. A, yes. So can we find T? For the time, we need to take the velocity time relation. V is equal to U plus ET. V is 0. U is 5 according to the question, plus A is minus 10 and T we need to find. So here 0, 5 plus minus 10T. If we take this side, it will become plus. So minus 10 becomes this side, becomes plus 10T is equal to 5. 10 is in multiplication, on that side it will go to denominator. So 5 upon 10, 5 to that, it will cut with 5 to that 10. So 1 upon 2 and it will be half. So half second. It means that the stone will take half second, 0.5 second. That means half second to reach to the height in this upward motion. So very simple examples to and using these equations of motion, we can solve these simple problems related to motion. Okay, so write this all examples in your notebook, and still if you have any doubt, you can ask me. Thank you.